So a lot of us saw in our exploration that they cause a reflection or it to flip, right? And when that was on the outside of my function, remember it's almost like a vertical flip. It flips over our x-axis, so it vertically flips over. And when it is inside my function, it's almost like a horizontal flip, right? It flips over our y-axis. So again, outside things usually affect things vertically, and inside things usually affect things horizontally. So let's look at an example of this. We're going to find an equation for the reflection of f of x equals 5x minus 9 over x squared plus 3 over each axis. So when I go to flip that over our x-axis, what I'm doing is I'm doing the opposite of f of x. So negative f of x. Let's make it green. So that means I'm going to have a negative and then my function. F of x, or sorry, 5x minus 9 over x squared plus 3. Okay, so since my function, my f of x is this whole function here, the negative goes outside of that whole function. Now, when we distribute this negative into our fraction here, it only distributes into the numerator. It does not distribute into both the numerator and the denominator. So this is going to be, well, negative times 5x is negative 5x. And negative times negative 9 is positive 9. And then nothing happens to our denominator. Now, when I flip it over the y-axis, the negative goes inside of our parentheses. So now, every time I see an x, I am replacing it with negative x. Okay, so I have 5 times negative x minus 9 over negative x squared plus 3. Okay, and then I'm going to simplify that. So 5 times negative x is negative 5x. And then I have minus 9. Negative x squared. A lot of us got things like this incorrect, even if it's just like a number on our quiz. A negative times a negative is positive. So a negative x times a negative x is positive x squared. All right, so be very careful with those little positive and negative things. So we get negative 5x minus 9 over x squared plus 3. So now these answers are very similar, but we got them doing very different things, okay? So they are different, right? So we do have to be careful of which axis we're reflecting it over and where we put like that negative. So what we just saw here, right, is we have these things called horizontal stretches and shrinks. Okay, so we see that first one is our horizontal. I want to make sure it's on my big board so I can write. Our first, right, horizontal when it's on the inside. And as you see here, like this is the weird part. That it's a stretch by 1 over c when it's the smaller number, or it's a shrink by 1 over c if it's a bigger number. So if the number is smaller than 1, it's actually stretching it. That's that opposite part that we kind of encounter here. Where if it's greater than 1, if it's much, much bigger, it's actually shrinking it. Where for a vertical stretch or shrink, that is not the case, right? We have y equals c times f of x. That c is on the outside. I like that too. And it's just c when, right, it's a stretch when c is greater than 1. Just c. Okay. So they kind of are opposite of each other again. So let's look at an example. So we're going to find an equation for the following non-rigid transformation. So these are non-rigid. Again, that means it's distorting it, right? That's that stretching and that shrinking. So f of x equals x plus 1 cubed. I want to stretch it by 3, a vertical stretch by 3. At some point, I had a stylus, there it is. So again, since it's vertical, a vertical stretch is on the outside of your function. So we're going to do 3 times f of x, which is just 3 times x plus 1 cubed. Nice and easy. Now, if I really mean, I would make you multiply out x plus 1 cubed by multiplying x plus 1 times x plus 1 times x plus 1, but we won't be that mean. So you can just leave your answer like that. 3 times x plus 1 cubed. For part B, we have f of x equals the square root of x minus 4, and we want to horizontally shrink that by 1/2. This is the weird part, okay? Because if we go back up above, right, when we shrink by 1 over c, we put a c here. I can't just, when we're doing horizontal shrinks or stretches, I can't just throw 1/2 in front. I have to figure out what c is first. Okay? So really, this 1/2, whatever it tells you your by whatever is really your 1 over c. When you have two fractions, the easiest way is just to cross multiply. 1 times c is c. 2 times 1 is 2. So my c value is actually 2. So that means my function is going to be f of equal, well, I write my function exactly how it is, but wherever there's an x, I'm going to put a 2x. We'll put the square root of 2x minus 4. Okay, let's look at one more example. So this one we're doing multiple things to it. So we want to do f of x equals x squared plus 4. We're going to horizontally stretch by 4 and vertically shrink by 1/2. So I'm going to start with this. I'm actually going to start with the vertical shrink by 1/2 because vertical is easier. That just means c equals 1/2, right? In your vertical, your c is just whatever it tells you it is. You don't have to do anything extra for vertical. For horizontal, right, that's where it's kind of like the flip of it, right? So whatever it is, 1 over c is what equals 4. If it helps you to always solve it the same way, this is the same as 4 over 1, right? Every number can be put over 1 to have it be a fraction. So I get 1 times 1 equals 1. C times 4 equals 4c. So that's just finding out what we're actually multiplying by. If you remember things from last year, you can think of it as your reciprocal, right? We found the reciprocal of 4. The reciprocal of 4 is 1/4. We're doing parallel and perpendicular lines. Remember, perpendicular lines have reciprocal slopes. Okay, so now we actually need to change our functions. Biggest thing, remembering that our vertical goes on the outside, our horizontal goes on the inside. So really what I'm finding is 1/2 f of, and then we have 1/4 x. All right, so I'm doing 1/2 f of 1/4 x. That's how I'm going to change my function up here. So I start with the 1/2, and I'm going to put it in parentheses, right? So I have 1/2. I'm going to put the rest of the function in parentheses because that 1/2 is being multiplied by my whole function. And then anywhere I see an x, I'm going to put more parentheses. So I have x squared right here. Right? So in that, I'm going to put that 1/4 x squared. Plus 4. Plus 4. Questions right now before I continue, because we are going to simplify this one. Any questions right now on anything we did? Okay, I am going to simplify this. So we work inside out. So I still have the 1/2. And I'm going to deal with these parentheses being squared. So since that's 1/4 x squared, that squared is on the outside, it's going to both the 1/4 and the x. Okay, so I kind of write it like that to remind myself, oh, when I have a squared outside of parentheses, I am squaring both of those things. So that equals 1/2. Well, 1/4 squared is 1 squared, which is 1, over 4 squared, which is 16. Squaring fractions is easy. So you can think of it as going to, this squared is going to all of these things. It's going to the 1, the 4, and the x, right? 1 squared, 4 squared, x squared. Then I just need to distribute in, so I have 1/2 times 1/16 x squared, which is 1 over 32 x squared. And 1/2 times 4 is +2.